There is a number in maritime history that has stood unbroken for decades, a number so large that the engineers who produced it were not entirely sure, when they first calculated it, that they were correct. A number that describes a ship so extreme that the phrase "largest ship ever built" does not adequately capture what it means. The Seawise Giant had a dead-weight tonnage, the maximum weight of cargo, fuel, ballast, crew, and provisions it could carry, of 564,763 metric tons. The Caterpillar 7997F haul truck, the largest mining truck, has a payload capacity of 363 metric tons. The Seawise Giant could carry more than 1,500 times the payload of the world's largest mining truck in a single voyage. No ship before it had approached this carrying capacity. No ship since has exceeded it. The vessel's length, 458.45 meters, exceeds the height of the Empire State Building, which stands 443 meters to its roof. Its draft, when fully loaded, the depth below the waterline, was 24.6 meters. It could not pass through the English Channel or the Suez Canal. It could not enter most of the world's ports. It was constrained to a handful of deep-water paths between the world's few capable ports. But before we get into the engineering, we need to understand the moment in history that produced it. The era was the late 1970s. The OPEC oil embargo of 1973 had quadrupled oil prices, triggering a global scramble for energy security. The Persian Gulf was the world's largest oil-producing region, and the demand for ultra-large crude carriers was enormous. The scale economics were compelling. A larger vessel carried more oil per unit of fuel consumed and lower cost per ton. The Seawise Giant was built for Seiwai Tung at Opama Shipyard in Japan, beginning as a smaller vessel and then extended during construction. The shipyard cut the partially constructed vessel and inserted a new midsection that added tens of meters to the length. The resulting vessel was the largest ever built. Its story, from record dimensions to its wartime sinking and return, is one of the most dramatic. The Seawise Giant was a single-hull tanker, built before the double-hull construction that became mandatory following the Exxon Valdez disaster of 1989. Its hull was a single steel shell, supported by transverse frames and longitudinal structural members, forming the cargo tanks that held crude oil. The structural challenges of building a 458-meter ship are qualitatively different from those of building a 200-meter ship. The hull bending moments scale with the square of the length. A ship twice as long experiences bending moments 4 times as large. A ship 4 times as long experiences bending moments 16 times as large. The steel required to resist these moments must be proportionally thicker. The Seawise Giant's structural design reflected the state-of-the-art in naval architecture of the late 1970s, sophisticated for its time. The structural analysis was done with calculation methods available in the era, lacking the resolution of modern finite element analysis. The cargo system, including tanks, pumps, and piping, was designed for the operational requirements of very large crude carrier voyages. Tanks were divided by longitudinal and transverse bulkheads into separate compartments. This provided flexibility for optimal trim and stability. The pumping capacity required was enormous. The vessel carried massive pumps capable of moving hundreds of cubic meters of oil per hour. A single discharge operation, pumping hundreds of thousands of tons of oil to a shore terminal, could take 2 days or more. The vessel's propulsion system was a single large 2-stroke diesel engine driving a fixed-pitch propeller through a massive shaft. With 50,000 horsepower, the Seawise Giant had a total displacement of approximately 657,000 metric tons when fully loaded. Moving that mass at 13 knots produced a formidable object in motion. The maneuverability was, as expected, extremely limited. A fully loaded stop from service speed required several nautical miles of sea room. Turning was slow and the radius was very large. Approaching a port required careful planning and typically a fleet of powerful tugboats to assist with the final berthing. The vessel's draft of 24.6 meters defined the operating constraints that ultimately limited its commercial utility. Its draft excluded it from the Suez Canal completely. It operated on routes around the Cape of Good Hope, the longest possible route. This routing constraint added thousands of miles to each voyage, consuming additional fuel and time, offsetting its scale economy advantage. As oil market conditions evolved in the early 1980s, the economic advantages of extreme-scale vessels became harder to justify. By the mid-1980s, the story that would define its legacy, its wartime destruction and subsequent salvage, was about to begin. The Iran-Iraq War began in September 1980 and lasted until August 1988. It was one of the most devastating conflicts of the 20th century, killing hundreds of thousands and displacing millions, and it was fought partly with oil money in a region that was, and remains, the center of global oil production. The war produced the Tanker War, a phase from 1984 to 1988 where both sides attacked oil tankers in the Persian Gulf. Iraq attacked tankers to reduce Iran's revenues, while Iran attacked neutral tankers calling at Kuwaiti and Saudi ports. The tanker war attacks, using aircraft-launched missiles and mines, damaged hundreds of vessels and killed hundreds of mariners. The Seawise Giant, renamed the Happy Giant, was in the Persian Gulf in May 1988, loaded with Iranian crude oil. Iraqi aircraft launched missiles and rockets at the vessel, igniting fires that spread across the enormous deck. The crew of approximately 40 people abandoned ship. Some did not survive the devastating attack. The fires burned for days, damaging the hull and releasing enormous quantities of burning crude oil into the Gulf. The vessel sank in shallow water in the Strait of Hormuz, with portions above water rather than sinking to impossible depths. The wreck lay on the seabed for months, a hazard to navigation and a seemingly unsalvageable mass of burned steel. What happened next was one of the most extraordinary salvage operations in maritime history. The challenges were immense. The vessel was in a war zone, and its structural integrity was unknown. The survey, conducted under wartime conditions, established that the hull structure was sufficiently intact for refloating. The cargo tanks were pumped out and the hull was patched using underwater welding to seal missile strike openings. The salvage team worked through 1988 and 1989 to recover something that most of the shipping industry had written off. The Seawise Giant was refloated in 1989 and towed to a shipyard in Singapore for repairs. The repairs took 2 years and cost approximately $60 million. The vessel was renamed the Jahre Viking. A vessel sunk by an air attack in the middle of a war had been recovered and returned to service. The Jahre Viking returned to trading as a storage tanker, moored at offshore terminals to store crude oil. Its enormous capacity made it one of the largest offshore storage options available in the world. The Jahre Viking continued operating as a storage tanker through the 1990s and into the 2000s, changing names and owners several times. In 2004, it was renamed the Knock Nevis, operating as a floating storage and offloading unit moored at the Al Shaheen oil field. As an FSO, it collected crude oil produced by offshore wells and stored it until it could be offloaded to shuttle tankers. The FSO role was well suited to the vessel's capabilities. The enormous storage capacity was a genuine advantage for collecting oil from multiple wells. The fixed mooring eliminated draft constraints, while stationary operation reduced mechanical demands on the propulsion system, extending the vessel's operational life. The Knock Nevis remained at Al Shaheen until 2009, when it was finally retired. The vessel was approximately 30 years old. Regulatory requirements for double-hull construction and extreme maintenance costs eventually contributed to the decision to retire the giant vessel. In 2010, the Knock Nevis was sold for scrapping. The largest ship ever built was towed toward its final destination. The vessel that survived air attacks and war was towed to a beach in India to be broken up for scrap steel. Shipbreaking is a labor-intensive process. Vessels are beached at high tide and cut apart by workers using hand tools. The scale of the Knock Nevis required weeks of operations. The steel recovered represented hundreds of thousands of tons of metal. The vessel's final resting place is scattered through the products of Indian steel mills, a conclusion to the story of a legend. The steel that formed the hull for 3 decades was recycled into buildings, vehicles, and machinery. The matter persists. Only the form changes. The Seawise Giant, in all its names, through all its owners, across all its voyages, teaches a lesson about scale beyond maritime engineering. It teaches that the pursuit of scale, taken to its logical limit, eventually encounters constraints that scale itself cannot overcome. The vessel was the most extreme expression of a scale logic that was correct in its essentials. Larger ships do carry more cargo per unit of fuel. They do require fewer crew members per ton of cargo. They do have lower operating costs per barrel of oil transported. These advantages are real, and they drove the economics of supertanker construction throughout the 1970s. But the vessel was also the demonstration of what happens when scale logic is pursued without sufficient regard for the constraints that scale creates. The draft that excluded it from the world's most important canals. The routing constraints that added thousands of miles to every voyage. The port infrastructure limitations restricted it to a handful of terminals. The enormous stopping distances and limited maneuverability were consequences of extreme scale. The history of large tanker construction after the Seawise Giant reflects the lesson. No vessel of comparable dimensions has been built since. The industry converged on the VLCC class of approximately 300,000 tons as the practical optimum. It captures economies while remaining versatile. The practical optimum is not the theoretical maximum. It never is. The Seawise Giant demonstrated this truth more dramatically than any smaller vessel. It was the experiment that proved the limits of the experiment, the machine that showed exactly where the boundary of practical scale lay. Stand on a chart and plot the voyage routes, the narrow corridors of deep water, and understand how small that network was. The largest ship ever built was also one of the most restricted. Its size was simultaneously its greatest achievement and its greatest limitation. Next, we move from history's largest trading vessel to the largest floating structure ever built, the Shell Prelude FLNG. It cannot move under its own power. It will spend its life processing natural gas off the coast of Australia, moored to the seabed. The next level of scale, the next frontier of extreme engineering, and the machine that answers the question of what comes after the largest ship. The numbers are extraordinary, the engineering story is even more so, and we are just getting started.